Hello everyone, how are you all? I hope you all are fine. I am Harkamal. Welcome to your own channel. So in our today's class we are going to discuss chapter number 5 of class 12, continuity and differentiability. So before we go through the questions, you have to know what is continuous function and what is discontinuous function. Okay, so let's get started. Firstly, continuous function. These are those functions in which when we plot a graph, it will be continuous. That is, there is no breakage. What does it mean? For example of continuity function is number 1 is identity function. Identity function means these are those functions when we put some value in x, we get the value of y. We get the same answer. We get the mirror image of it. Okay. For example, if we take a function that is f of x is equal to y. Okay. F of x means y. Okay. F of x is equal to y is equal to x. Let us assume this function. Okay. This is the identity function. Okay. These are those functions when we put the value of x, we get the same value of y. Right. Okay. Let us take the value. If I take value of x is 0, we get y is 0, right? If we take x 1, we get value of y is also 1. Okay. If we take x minus 1, we get y is minus 1. Okay. If we take x2, here x2, we get y is equal to also 2. Okay. If we get x, if we put x is equal to minus 2, we get y is equal to minus 2. Okay. So here if we plot a graph, okay, here it is, we take a value here, x0, when x0, y is also 0. Here it is. Okay. When x1, y1, okay, x1, y1, here is the point, and when x is minus 1, y is also minus 1. Okay. Here it is the point. Okay. When x is 2, y is 2. Here is the point. When x is 2, y is 2. Okay. When x is minus 2, y is also minus 2. Okay. Here is the point. Okay. I will explain you what is a continuous function. This is the example of continuous function. Okay. We take identity function. What is identity function? Means if we put the value of x, we get the same value of y. Okay. This is the mirror image. Okay. Okay. Then we have take the points. Okay. What does it mean, the continuous function? Okay. When we draw the graph, when we plot the graph, here is the point. I am plotting the points. Okay. I am plotting the graph. How I can draw? I can draw like this. Meet these points, and I am plotting the graph without lifting my pen. Okay. Can you understand? I am plotting the graph without lifting the pen. It means there is some continuity in the function. This is called the continuity function. Okay. Means there is continuous without any breakage. There is no breakage. I am plotting the graph. I am joining the point without lifting my pen. Right. This is called the continuous function. So here is the first example of continuous function is identity function. All identity functions are continuous. Okay. Then we have taken number 2 example of continuous function is the constant function. What is the meaning of constant function? Okay, when the value of y is equal to some constant value. Okay, if we take the function f of x is equal to y. Okay, if we take the function f of x is equal to y. Okay, then the value is equal to some constant value. Okay, we take the constant value is equal to 3. Okay. So here it is. In the next step we get y is equal to 3 plus 0x. why we have taken this 0x? Question put in your mind. Why we have taken here the 0x? 0x means, okay, 0x means something, when we plot the graph, we need both x and y axis, right? So that's why we have taken both y and x here. Here is not x, but we have taken so that we can plot the graph. Okay, 0x. Okay, here is the value x and y. If we put the value of x, we get the value of y. Okay, here it is. When we take x is equal to 0, when we take x is equal to 0, something multiplied by 0 is always 0. Okay, then the value of y remains 3. Okay, here it is. When x is 0, y is 3. When x is minus 1 multiplied by 0. Anything multiplied by 0 is 0. Okay, here it is. Y value is 3. When we take x2, y value is always remain 3, as this remains always 0. Okay, and when x is equal to minus 2, y remains 3. Okay, here when we plot this graph, okay, here is the point. When x0, y is 3. When x0, y is 3. Okay, when x is minus 1, when x is minus 1, y is 3. Here is the point. Okay, when x is 2, y is 3. Okay, when x is 2, okay, here it is. When x is 2, y is 3. Okay, when x is minus 2, when we take x is equal to minus 2, any point, okay, y, the value of y remains same. Y is equal to 3. Okay, this is the meaning of the constant function. Okay, where y is equal to 3. Then y value of y is 3. When x is minus 2, y is 3. Okay, these are the points. Okay, so let's plot these points. Okay, firstly, I am plotting the graph here. I am joining the points. Okay, right? So here is my pen and I am start plotting. Here it is. I am plotting the graph without lifting my pen. This is called the continuous function. Okay, when we plot the graph without lifting my pen is called the continuous function. Means there is no breakage at all. Okay, we have the third example of the continuous function is polynomials. Okay, all polynomials are also continuous. How? Let us take the function. If we take y, that is f of x is equal to y. Okay, y is equal to x square. Okay, when we take y is equal to x whole square, then if we put the value of x, we get the value of y, as we know that. Okay, let us take the value of x is, when x is 0, y is 0. Okay, when we take x is 1, y is again 1, right? If we take x minus 1, this becomes the positive value, as this is a whole square. Okay, we get y is equal to 1. When we take x2, 2 whole square is 4. Okay, when we take x is minus 2 whole square is 4. Okay, this gives a positive value, as this is a whole square. Okay, when we plot this graph, okay, let us take the point when x0, y0. Okay, x0, y0. When x is 1, y is 1. Okay, when x is 1, y is 1. This is a point. When x is minus 1, y is 1. When x is minus 1, y is 1. This is the point. When x is 2, y is 4. When x is 2, y is 4. Okay, this is a point. When x is equal to minus 2, value of y is 4. Okay, when x is minus 2, the value of y is 4. Okay, these are the points. So join these points, we get, here it is. When we plot the graph and join the points, I am plotting the graph without lifting the pen. This is called the continuous function. There is no breakage at all. So here we conclude that all polynomials are continuous. Okay, so our next example of the continuous function is the modulus function. Okay, here it is modulus function. We have taken the function y is equal to mod of x. Okay, so here we take the value of, here when we put the value of x we get the value of y. So let's get started. Okay, so when x is 0 y is 0, when x is 0 y is 0. Okay, when x is a 1 then y value is corresponding is also 1. Okay, when x is -1, the modulus of -1 become positive. Okay, in modulus case. Okay, this becomes 1. When x is 2, when x is 2 y is 2. When x is -2, the value of y becomes 2, that is positive. Okay, when we plot this graph we get when x 0 y 0, here the point, when x is 1 y is 1, when x is 1 y is 1. Okay, when x is -1 y value is 1, when x is -1 the value of y is 1. Here's the point. When x is 2 y is 2, when x is 2, when x is 2 y is 2. Here's the point. When x is -2 the value of y is 2. Okay, when x is -2 the value of y is 2. Here it is, here is the point. Okay, so we get all these points, so let's start plot it. So join these dots. We are plotting the graph without lifting the pen. So this type of function is called the continuous function. So modulus function is also continuous function. So next we have the trigonometric function. So let us check the continuity. Okay, sin x, cos x, these both are continuous function. How? Let us explain. Y is equal to, let us take the example, let us take the function y is equal to sin x. Okay, we have taken this sin x to check the continuity of the function. Okay, how we can check? We can check by taking the value of x, we get the value of y. Okay, let us take when x is 0 y is 0, sin 0 is 0. Okay, when we take x pi by 2, when we take x pi by 2, sin pi by 2 is 1. Okay, when we take x is pi, sin 180 is 0. Okay, when we take sin 3 pi by 2, sin 3 pi by 2 is -1. Okay, okay, then we have the points. So let us plot the graph. Okay, so here it is, when x 0 y is 0, when x is 0 y is 0. Okay, when x is pi by 2 y is 1, when x is pi by 2, when x is pi by 2 y is 1. Here is the point. Okay, when x is pi then y is 0, when x is pi y is 0. Here is the point. When x is pi y is 0. Okay, then when x is 3 pi by 2, value of y is -1. Okay, here is the point. When x is 3 pi by 2, y is -1. Okay, so let us plot the graph. I am plotting the graph without lifting the pen, and this type of function is called the continuous function. So that is why sin x is the continuous function. We have proved it. Okay, and similarly cos x is also the continuous function. Okay, then let's check tan x is continuous or discontinuous function. Okay, so tan x is equal to sin x over cos x, as we know that. Okay, so if we take x is equal to pi by 2, if we take x is equal to pi by 2, cos pi by 2 is 0. Okay, so here it is, when we take x pi by 2, here it becomes 1 over 0. 1 over 0 means the function will become indefinite. How? The function shouldn't be equal to indefinite, shouldn't be equal to infinity, shouldn't be equal to infinity. It should be a number. Okay, so that's why tan x is a discontinuous function. So that is why tan x is discontinuous function. So next is the discontinuous function. So let us take an example. Example of discontinuous function is the signum function. What is signum function? Okay, let us take the function y is equal to modulus of x over x. Okay, for example, f of x is equal to, we take the function f of x is equal to this type of function 1, value of y is 1 when x is greater than 0. Value of y is 0. These are the values of y. Value of y is 0 when x is 0. Okay, the value of y is minus 1 when x is less than 0. Okay, so we have taken these points. Okay, here 0. Okay, when x is greater than 0, I have taken when x is greater than 0. Greater than 0 means 1, 2, 3, any value, not minus values. These are positive values. When x is greater than 0, here it is. Here is the value. When x is greater than 0, 0, 0 greater than. Okay, for example 1, 2, 3. Okay, if we have taken when x is 1, value of y remain 1. Okay, if we take x2, the value of y remains 1. It may be any value, is x is greater than 0, any value in the right. Okay, okay, then when x is 3, if we take x3, if we take x3, okay, if we take x3, this is greater than 0, no? Okay, if we take x3, the value of y remain 1. Okay, so these are the points. Okay, when x is less than 0, when x is less than 0, less than 0 mean this is the 0, less than 0 mean this side, negative side. Okay, this side. Okay, if we take x is minus 1, if we take x minus 1, value of y, these are the values of y, value of y remain minus 1. Okay, value of y remain minus 1. Okay, if we take x is minus 2, if we take x minus 2, okay, x minus 2, value of y remain minus 1. Okay, here it's the point. When x is value, when we take x is equal to minus 3, like this, okay, the value of y remain minus 1. Here is the point. Okay, now when x is 0, value of y remains 0. Okay, so here we go. Let us join these dots. Okay, I am plotting the graph. Here it is. I am joining the dots. I am joining the points. Okay, here I am lifting my pen. Okay, here I am lifting my pen. Here it is. I am joining. Okay, here while plotting the graph, I am lifting my pen. It means there is some breakage. Okay, this type of function is called the discontinuous function. So signum function is an example of the discontinuous function. So next is our greatest integer. So we have take the function y is equal to greatest integer x. Okay, it means these not having the numbers, not having the fractions. Okay, if we take the value of x, we got the value of y. Okay, for example, when we take x is equal to 1.2, okay, 1.2, 1.23, 1.24, any value in between 1. Okay, if we put x is equal to 1.2 or 1.23, 1.24, okay, any value. Okay, we get y is equal to always this one. Okay, this is the greatest integer. It shouldn't have any fractions. Okay, we get the value of y is this one. Okay, when we take x is equal to 2.23, okay, any value, 2.24, 2.25, any value. Okay, when we take x is equal to 2.23, if we take x is equal to 2.23, we get the value of y is, it shouldn't have any fractions, so that's why it becomes this 2. Okay, so when we take x is equal to 3.24, we get the value of y is this 3. greatest integer. Okay, when we take x is equal to minus 1.23, its name is greatest integer, but it gives lowest value. Okay, then in case of the negative, we get the value of y is minus 2, not minus 1. This gives the lowest value, minus 2. Okay, if we take minus 2.23, it will again give the lowest value in case of minus. Okay, it gives minus 3. Okay, so let us check the continuity of the function. So here we plot the graph. So when x is 1.2, when x is 1.2, in between this value, any value in between, here it is 1.2, it may be 1.2, it may be 1.23, it may be 1.24, 1.25. Okay, but the value of y remain 1. The value of y remain 1 when we take the fraction 1.2. Okay, at 1.2 we get y is equal to 1. Okay, if we take here 1.2, 1.3. Okay, if we take here 1.3, okay, let's check 1.3, the value of 1 remain 1. Okay, when we take x is equal to 1.4, at 1.4 we get y is equal to 1. Okay, we get y is equal to 1. Okay, when we take x is equal to 2, when we take x is equal to 2, the value of y is 1. When we take x2, here it is, when we take x2, the value of y is what? Y is not 1. Okay, is not 1. That is why we are using this symbol. Okay, so at x is equal to 2, at x is equal to 2, the value of y is not 1. Okay, so similarly when x is 2.23, when value of, we have taken x is equal to 2.23, x is 2.23, here it is, the value of y is 2, right? Value of y is 2 when we take x is equal to 2.23. Okay, if we take x is equal to 2.3, if we take x is equal to 2.3, it may be any point in between. Okay, if we take x is equal to 2.23, the value of y is greatest integer, it gives the value always 2. Okay, this here 2. If we take value of x is 2.4, okay, we get the value always 2. We get y is equal to this 2. Okay, here it is. If we take x is equal to 3, if we take x is equal to 3, this 3, then value of y will become, value of y will become also 3. Okay, this is not, y value is not equal to this. Okay, so that's why we use this symbol. Here it is. So similarly when x is equal to minus 1, 2, 3, when x is equal to minus 1, 2, 3, 1.23, when x is equal to minus 1.23, here is the point, y is minus 2, here is the point. Okay, when x value is 1.3, value of y remains minus 2. When we take x value minus, this is a minus sign, minus 1.4, the value of y remain minus 2. We have these points. Okay, when we take x value minus 2, the value of y is not equal to minus 2. Here is a symbol. Okay, so when we plot the graph, join these points like this. This is the ladder type graph. Okay, so I am plotting the graph with lifting my pen. Okay, this type of function is called the discontinuous function. So instead of plotting these graphs, we have the alternate method. This method is called the limit method. Okay, if limit exists, the function is continuous. Instead of plotting the big graphs, we have the limit method to check the continuity and discontinuity of the function. Okay, if limit exists, the function is continuous. Okay, what does the meaning of limit? Limit means very, very near. Limit means very, very near. Okay, when x, this symbol means tends to or approaches to. Okay, for example, if we take the function f of x is equal to x square plus 3x. Okay, if we take this function, okay, as x square plus 3x, if we have to check the continuity of the function at this point 2. Okay, here x approaches to 2. It means x value is not 2. It means it approaches to 2. It's very near to 2. It may be in the left of 2. It may be on the right of 2. Okay, so it may be in the left is 1.99, or we can say in the right it may be 2.001. It's very near but not 2. Okay, for example, here is a function f of x. If we have to check the continuity of the function at point C, if we have the value f of c, on taking the limit, left hand limit and on the right hand limit, if these three values are same, f of c, at which we check the continuity of the function, is equal to left hand limit is equal to right hand limit. If these three values are same, the function is continuous. For example, if we take the function f of x is equal to x square. Okay, let us understand what is this. Let us taking by example f of x is equal to x square. Okay, so we have to check the continuity of the function at x is equal to 5. Okay, so here is f of 5, here is x is 5. Okay, directly if we put directly value f of 5, okay, instead of x we have to write 5 here. So on putting this value we get value of f of x is equal to f of 5 is 25. Okay, so we have to check the continuity of a function. So we have to check the continuity of function at x is equal to 5. Okay, it means the value of x is not 5. It means x approaches to 5. It means the value of x, it may be in the left of 5 or maybe in the right of 5, but it is very, very near. Okay, so in the left it may be 4.99. Okay, in the right of 5 it may be 5.001. Okay, so how we check this function is a continuous or discontinuous function? So without plotting the graph. Okay, so here firstly we directly put on where we check the continuity of the function, that is 5. Directly we have to put x5. Okay, we get 25. Okay, on putting directly value of x5 we get 25. Okay, so let us check on the left hand limit. Okay, so in the left hand limit we get limit x approaches to 5 left hand limit. On the left hand limit of 5 we get limit x approaches to 5 negative. There is a negative value. Okay, so that's why we have put this sign. The function is x square, we have right here. So put x is equal to 5 minus h. How? If we take x5. Okay, so if we take the left hand limit we have to reduce some value. Okay, we have to reduce some value from 5 so that we get this value. Okay, we have to reduce some value. So this value which is reduced, which is very, very small, as I say, which is very, very small, we have taken is h. Okay, so that's why we put x is equal to 5 minus h. Okay, so here we go, limit h approaches to 0 negative, 0 left. Okay, so as we said that the value of h is very very small, so that we can get this number. The value of h is very very small, so small number, that's why we have taken h approaches to 0 left. That's why we have taken 0, which is very small. Okay, so here we put the values 5 minus h whole square. H value is very small, so here we put the value of h is 0 on the next step. So here we get 25. 5 whole square is 25. Okay, we get 25 here, and 25 on directly putting the value of x, we get this value. Okay, so on the right hand limit, let us check on the right hand limit. Okay, limit x approaches to 5 right. Okay, it may be value 5.001, it may be 5.001, which is very small. Okay, limit x approaches to 5 positive means right. Okay, so here is the function x square, so here it is. So here this is 5 right. Okay, so we have to add some value. To get this number 5.001, 5.01. So we have to add some value, but addition is very very small. Okay, this is h. Okay, 5 plus h whole square, on putting x is equal to 5 plus h. Okay, so here we go, 5 whole square is 25. So here h approaches to 0. This h is very very small, that is why we have take h approaches to 0. So here we go, is equal to, right hand limit is equal to, we get answer 25. So on taking the value f of x, as we get the answer 25 here. On putting this value, left hand limit, we get the answer 25. On taking right hand limit, we get the answer 25. Okay, this means these three answers are same. So in this case, the function is continuous function. So if you like a video, so kindly subscribe our channel. Thank you so much.